Hello. We are moving on today to scientific notation. So last notes that we did covered percent error, and then we talked about laws of exponents. And the reason why we talked about laws of exponents is because we're going to take these laws of exponents and talk about them in terms of scientific notation. Now, the really cool thing here is that you can use your calculator all the time, right? We don't really actually need to know laws of exponents in regards to scientific notation because you can just use your handy dandy calculator and it'll tell you what the answer is. So we're going to practice using our calculator in regards to scientific notation, how to recognize it in our calculator, and how to handle it. So scientific notation. Scientific notation is a way to represent numbers that are really, 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 really big or really, 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 really small. So if we were to talk about a number that was really, really, really small, we could talk about something like 0.000013579. And writing all those zeros out would be crazy. Not crazy, but it's just inconvenient. And so we want to talk about it in a way that's a little bit easier to understand, a little bit if you're writing that same number over and over again. It's just a good way to write it out. So how we handle scientific notation is that we have a number multiplied by 10 to the power of something, 10 to the power of something. So this number right here needs to be a number between 1 and 10. Really what that means is that if I were to have a decimal, right? Decimal meaning point something something, which is different than the Italian way of writing it, right? So we're talking about the American way to write it. We need to just have one digit in front of here. That is our goal. That's what this range means, is that A needs to just have one digit in front, and then you can have as many digits as you want behind. But it just means that there's only one number in front of the decimal. All right, K. We have two different options for K. K could be positive. And if it is positive, then it is a really big number. And that's all you have to remember, that if it is a positive exponent for 10, that means that this number is big. Really big could be relative. Notice below, like 35 would count as a big number because it has larger than one digit in front of the decimal place. And so it'll count as a big number. We'll talk about it later. But relatively, it means that it is a big number. If K is negative, then it is a really small number. Okay, so if it's a negative exponent up here, then it's a really, really small number. A lot of times when we first learn scientific notation, when we're talking about going back and forth between scientific notation and just regular notation, is that we say, okay, well, if it's a positive, then we're going to move the decimal to the right this many times, or if it's negative, we're going to move the decimal to the left this many times. But that can get really confusing because we start to flip around when we move the decimal in the right direction, or in a certain direction. So all you need to remember is that if it's positive, you need to move the decimal to make it a bigger number. If the exponent is negative, then you need to move the decimal to make it a smaller number. Decimal to scientific, K means whatever K is, whether it's -3 or +3, it means that you jump 3 times. So K tells you how many times to jump the decimal. By jump, I mean moving that decimal over and then filling in the bowls with zeros if you need to. Again, -K means small. +K means big. All right, so let's practice that for a second. We want to transform, let's do 65,000. Remember that this comma is not a decimal, it is a comma, meaning 65,000, a big number. If you do not see the decimal is at the end. So we see the decimal here. We know exactly where it is. We don't see it on any of these. That means that the decimal is at the end. We want to move that decimal so that there is only one digit in front of the decimal. So 6 would have to be in front of the decimal. So now we're counting how many times do I have to jump that decimal in order to get it to this spot. And so you count 1, 2, 3, 4. That is 4 jumps. So what I do is I take that number and now I write it in my A form. So this is A, which is between 1 and 10. Notice 6.5 is between 1 and 10. And really all that means is that we have one decimal in front of, one digit in front of the decimal. So we've got 6.5 times 10. It is a big number, so our exponent is going to be positive, and we've jumped 4 times. So it is going to be positive 4. And you're done. Moving on to these guys, these can be a little bit confusing because you're like, 35 is not really a big number, but it is compared to other numbers that are out there. In scientific notation, 35 is a big number. So if the decimal is here, that means that we need to move it once to make it 3.5. Again, remembering we want only one digit in front of the decimal. 3.5 times 10, we moved it once, and since it was a big number, it's going to be positive. Positive 1. 146, big number. We want to move that decimal here between the 1 and the 4. We have to jump it twice in order to get there. So that's 1.46 times 10 to the positive 2. 2 because we jumped twice, positive because it's big. 78.65 is larger than 10. So we can say means big, larger than 10. We want to move the decimal then such that there's only one digit. So it becomes 7.865 times 10. We jumped it only once, and since it was big, it's going to be positive. 5. We've got 300 million. If we don't see the decimal, it's here at the end. We want to move it after the 3. So that means that we're going to jump it 3, 6, 7, 8. Yeah? So we've got 3.0, or 3, times 10 to the positive 8th power. All right, 0.1 is less than 1, which means that we're going to move the decimal to be after 1. So it's going to be 1 jump, but since it was a small number, now that exponent is negative 1. Moving this guy here, again, it's a small number, so we know our exponent's going to be negative. We have to jump it once, twice to get between 4 and 5. So we have one digit in front of the decimal. Times 10, 2, because 2 jumps. Negative, because it was a small number. 1, 2, 3, 6.07 times 10 to the negative 3. So that is scientific notation in a nutshell. Now what happens actually is when we're using our calculator, sometimes we'll get something like 5.0135246. E, negative 3. So this is on your calculator. Okay, what happens is that E right there is scientific notation. It is telling you that it is scientific notation. So that really means 5.01 times 10 to the negative 3. That is all it means. So when you see that pop up in your calculator, it's just telling you that it's scientific notation. It means it's, hey, it's a really small number. All right, so let's practice all of the operations with scientific notation. Albert Einstein's famous equation E equals mc squared relates energy, joules, mass, kilograms, and speed of light, C equals 3.0 times 10 to the 8 meters per second. Calculate the energy of a proton. The mass of a proton is that. So this is all in scientific notation because the speed of light is really, really fast. It has a very high speed, right? And the mass of a protein is really, really, really small. I don't want to write all of those zeros, and so this is how we write that number. So it gives us an equation. To prepare for any problem, you should first write down an equation. And we prepare before we ever start calculating, because that's really important, especially in IB, especially in applications, okay? So first we're gonna write down our formula, and our formula is our recipe. And this recipe says, hey, we've got all of these ingredients that you need to go find. We have M. M is the mass, right? The mass of this proton is 1.67 times 10 to the negative 27 kilograms. We also have C. The speed of light is 3.0 times 10 to the 8th meters. So remember, with our laws of exponents in our previous day, in our previous notes, that to the negative 1 means 1 over that thing. So this is a weird IB way of saying meters space second to the negative 1, which is meters over seconds, because it becomes meters times 1 over seconds, which becomes meters over second, meters per second. So that's the unit of measurement there. You will see that with every single rate that you have, whether it's a speed or whether it's some sort of rate, a going rate, a charge rate, anything like that, is all going to be represented like this with this negative 1 exponent. All right, so we have our recipe and we have our ingredients, and so now we're going to take all of these numbers and plug it into this equation. So I want to solve for E. You can even write over here, E equals question mark, which for me is a really great visual cue of like, wait a minute, what am I solving for? Because sometimes we get really deep into a problem and we're like, we kind of lose track of where we're going for. And this little E equals question mark is a nice little visual cue to be like, oh, that's right, we're solving for energy. So first we plug in mass, 1.67 times 10 to the negative 27. C, which is 3.0 times 10 to the 8th power. And notice that C is squared, so we have to square that. Do not do this by hand because you are allowed to use your calculator, and let your calculator help you. So go ahead and plug it all into your calculator. I'm going to do this into parentheses. I'm going to put this in parentheses. If you don't know how to type any of this into your calculator because you can't see my fingers or something like that, write a note to yourself right now and say, I need Megan to show me how to type this into my calculator. And so then I will go ahead and do that when I see you next. I'm going to plug the 3.0 times 10 to the 8th. Remember that we have to square it, so I'm going to scroll outside of the parentheses, and then I'm going to square it and press enter. Notice here that E is there again, like we were talking about before. And that E, it is scientific notation. So that's 1.503. E negative 10 means times 10 to the negative 10th power. And that is all you have to do. You're done.